Again, we've got a few different types of problems that you're going to see on the final exam here. One with the square, one with the square root, one with c's in a bunch of different places. So this would be good practice getting ready for the final. With the problem with the square, after we circle our variable and draw our line of equality, there's one other thing I want to do before we get started, before we start getting rid of things. Box what? The square. So should I just put it like that?
No.
Okay, we also want to put it around everything that's being squared, which is the a plus 1. So remember, when a square is on a parentheses, that parentheses, the whole thing is being squared. Now, the reason we put that box there is so that we know we have to get that by itself before we can get rid of the square. Is there anything outside of the box that we need to get rid of before we can get rid of the square? No. So we're just going to move straight to getting rid of the square. And how do we get rid of a square? We take the square root. So the opposite of a square is a square root. So we're going to take the square root on both sides of the equal sign. On the left side, the square and the square root cancel each other out, which leaves what? A plus 1. Do I need the parentheses anymore?
No.
No. If I put the parentheses there, it's not wrong. But there's nothing else left over there, so I don't need to group those together. And on the right side of the equal sign, we're taking the square root of 9, which means we're looking for a number that multiplies by itself to get 9, which would be 3, or negative 3. So negative 3 would also work here, because negative 3 times negative 3 is positive 9. So we need to write two different equations. The one equation, we're going to have 3 on the right side. The other equation, we're going to have negative 3 on the right side. What's going to be on the left side of this equation? A plus 1. So we do need to have both of these equations there, because 3 times 3, or 3 squared, is 9, and negative 3 times negative 3 is also 9. Now we're going to keep solving like we normally do. So we're going to get the a by itself here by doing what? Subtract 1. And when those 1's cancel on the left side, a is all by itself. That's good, because that's what we're trying to do. 3 minus 1 is 2. So there's one of your answers. And then the other one, the other equation, we want to get the a by itself there. We're going to do the same thing. We subtract 1 on both sides like we did over here. And the 1's cancel on the left, leaves a by itself on the left side, and negative 3 minus 1 is?
Negative 4.
Negative 4. And that is the second of the two possible answers. So we get 2 or negative 4. And just like all the equations, if we would go back and check it, how would we check this? Yeah, we would take these numbers here, the 2 and the negative 4. We do it one at a time. Take the 2, plug it in here for a in the original equation, and then see if we get the same thing on both sides of the equal sign. All right, and if we did that with both of these numbers, it would work. This one's going to go a little quicker, I think. So we're going to set this up the same way. We circle the variable, draw a line of equality, and then I also need a box around what? The square root. Again, this box is a reminder that I need to get it by itself before I can get rid of the square root, because I do need to get rid of that square root before I can do anything with the 7 or the 5. So what do I need to do to get the square root by itself? Emily? Good. We're going to divide by 4 on both sides, and that's going to cancel the 4 on the left, leaving the square root and everything that's in it, 7b minus 5. And on the right side, 12 divided by 4 is? 3. Okay. Then, well, that was the only thing outside the box, right? So that's all we had to get rid of to get the square root by itself. So now let's get rid of the square root. How do we do that? We're going to square it. So we square the square root. Remember, the square goes up and to the right. So we square that. So we're going to square the other side also. Square and square root cancel each other out, leaving what? Okay. So we get 7b minus 5 on the left. And on the right, 3 squared. 3 times 3 is? 9. Could it be negative 9? 3 times 3 could be negative 9? No. It's a positive 3 times positive 3. It's always going to be a positive 9. So at these problems, when we're squaring it, you're not going to get two different answers. You're only going to get one answer. Now what?
Add 9. Add 5.
Add 5 on each side to get rid of that minus 5. The 5's cancel each other out, leave 7b equals 14. And then divide each side by 7. And those 7's cancel each other out, leaves b equals 2. this next one here looks kind of complicated. It's got a bunch of stuff going on, but it's actually not too bad, I don't think, if we just go step by step. First thing we're going to do is circle the variables, and we notice here that we've got more than one c, and the c's are on both sides of the equal sign. So we're going to have to do some simplifying, and we're also going to have to do something else to get the c's on one side of the equal sign so that we can get it by itself. So we've got variable circled, line of equality. What are we going to do first? Distribute. We're going to distribute. There's actually three things we can distribute in this problem. So starting with that 5, what's 5 times c?
5c.
5c, and what's 5 times negative 3? Negative 15. Then when we distribute here, we're actually distributing not a 4, but a negative 4. So negative 4 times 2c is? Negative 8c. And negative 4 times negative 5 is?
20.
Positive 20. Oh, that's not a 2. Positive 20. All right, then on the other side, we're going to distribute that 3. 3 times c is 3c, and 3 times 5 is positive 15, and we'll bring down that minus 22. That's the only thing that didn't distribute in the whole problem. All right, after we distribute, then we combine like terms. So on the left side, we've got a 5c and a negative 8c. What's 5 minus 8?
Negative 3c.
Negative 3, so we get negative 3c. And then we also have a negative 15 and a positive 20, gives us positive 5. Okay, then on the other side, we've got a 3c. Well, that 3c doesn't combine with anything, does it?
No.
So we'll just bring that down. And then we have the 15 minus 22 is negative 7. All right, and then equal sign on the line. Every step along the way, we're going to simplify it. All right, now I have c's on the left side and I have c's on the right side. I only want c's in one place so I can get it by itself. So what do we do next?
I can get rid of it.
Okay, why are we going to get rid of the minus 3c instead of the positive 3c? Yeah, because it's smaller. So the number that's smaller, the coefficient that's smaller, we're going to get rid of. In this case, we're getting rid of the negative one because a negative is always smaller than a positive. All right, so we add 3c on both sides. That's going to cancel out the 3c's on the left, leaving 5. And 3c plus 3c is 6c, and we still have our minus 7. And now that we have c in one place, we're back to what we were doing at the very beginning of the triad with the two-step equations. Just get rid of the 7, get rid of the 6. So how are we going to get rid of the 7? Add 7. 7's cancel on the right, leaving 6c. And on the left, 5 plus 7 is? Okay, then what? Divide by 6. And when those 6's cancel, on the right we get c, and on the left we get 2. Now, I know I said this already, but this is not a problem that you're going to see on the final exam. It's not something that we've done a lot in class, but we've seen these types of problems in openers a couple of times. This is not an equation. What is this called? This is called an inequality because what this is saying, what this symbol says, is that one side is bigger than the other. Actually, what it says in this one is that the left side is less than or equal to. This line underneath here means or equal to. So the left side could be less than or it could be equal to negative 12. All right, so we call this an inequality, where if it was an equal sign, we would call it an equation. It's an inequality because it says one side is bigger than the other. All right, so the two sides are not equal. They could be equal to each other, and that's what that line underneath means, but they're not necessarily equal. We know one side's bigger. So what do I do to solve this? How do I start? Yeah, we're going to start the same way we always do. We're going to circle a variable and draw what we call the line of equality. If you really want to, you could call this a line of inequality. But that line right there is going to be what separates the left side from the right side. And just like when we solve an equation, whatever we do on one side, we have to do on the other. All right, so I need to get this d by itself by getting rid of this negative 3/5. How should I get rid of this negative 3/5? Emily? Exactly. We're going to divide by negative 3/5. This is multiplication. This 3/5 is right next to the d, so it's negative 3/5 times d. So we're going to divide by negative 3/5. Now, there's kind of a shortcut to this. When we divide, you guys remember the acronym that we use for division? KFC, you guys remember that? What does KFC stand for? Keep, flip, change. So if we're going to divide by negative 3/5, I'm going to write this off to the side here. Divide by negative 3/5. That's the same thing as doing what? Multiplying. So we're changing it to multiplication. So it's the same thing as multiplying by. We're going to flip it and get 5/3. And it's a negative, right? So instead of dividing by negative 3/5, we can just right off the bat and multiply by negative 5/3, and, well, that's going to take care of it for us. So another way to look at this here, let's see what happens. If we write, negative 5/3, what's going to happen with the 5s on this side? They're going to cancel each other out. And what's going to happen with the 3s over here? They're going to cancel each other out. And what's going to happen with the two negatives? They're going to cancel each other out. So when we flip it and multiply, then we're going to have those numbers all canceling each other out on the left. Now the problem is we multiplied by negative 5/3 on the left, so we have to do it on the right side. So we have to multiply by negative 5/3 here also. All right, so on the left side, what do we have left? Just D, all by itself. On the right side, we need to multiply that out. So we got to remember how to multiply fractions, right? How do we multiply fractions? What do we want to do first? Yep, see if you can simplify. So we're going to make that 12 over 1. And we're going to look for anything in the numerator that can simplify with anything in the denominator. The only thing in the denominator that can simplify is the 3. So is there anything in the numerator that'll simplify with it? The 12, right? What goes into 12 that also goes into 3? How about 3? So we divide by 3 and get 1 on the bottom and 4 on top. Whew, this is fun, isn't it? A lot of stuff going on here. There's even more coming up. So what do we get? What's 4 times negative 5? Negative 20. And it's negative 20 over 1, but do we need that over 1? What's negative 20 divided by 1? Negative 20, right? So we're just going to leave that off. Now the last thing we need to do, we've got the D by itself, we've got the right side simplified, we need to figure out what's going to go on the line here. It's not going to be an equal sign. This is not an equation. Okay? Is it going to be the less than or equal to? This is kind of a tricky thing. Are we just going to bring this down? No. You guys remember what happens when we multiply by a negative number? When we multiply by a negative, then negative numbers become positive and positive numbers become negative. So everything flips over on the number line when we multiply by a negative number. So since the number line is flipping over, then what do we need to do with this? We need to flip that over. So instead of less than or equal to, it's going to be greater than or equal to. It could still be equal, but we're going to change the less than part to a greater than part. Okay, we only do that when we what? When you multiply or divide by a negative. So when you're solving inequalities and you multiply or divide by a negative, we have to flip the inequality. And there's your final answer.